Now let's take some time to do a deep dive into slope. The slope is the ratio of a line's vertical change to its horizontal change, often referred to as rate of change, and is denoted in our formula by the letter m. So when we look at how a slope works and how the rate of change works, we can pick any 2 points on our line, and it will always be the same with a linear equation, and say this point is x1 sub y1, x sub 1 and y sub 1, and this is another point with an x and y value. We have to look at how much the point has changed horizontally along the x-axis, as well as how much the point has changed vertically along the y-axis. We can call the horizontal change a run and a vertical change a rise. And the way we find the difference in its horizontal change and its vertical change is we subtract the 2 points from each other, the x component, and we subtract the y component. And so we often think of slope as the ratio of the rise over the run, which gives us this formula where the difference in the y values. We can also, if you're physics inclined, you may see delta y compared to delta x, which just means the change in y divided by the change in x. So we have our slope formula where y2 minus y1 divided by x2 minus x1. Which point is x1 and y1 and which one's x2 and y2 doesn't matter as long as you're consistent in your points. x2 minus y or x2 minus x1, as long as they're not the same, then our slope formula works out. However, if they are the same, we end up getting a denominator of 0. And if we have a denominator of 0, then we have what's undefined, and we get an undefined slope. And so we can see a practical example here with this slope. Picking any 2 points on this line, we see that we have a vertical change of 4 units, and we have a horizontal change of 2 units, giving us the ratio of 4/2. And again, with these 2 points, same thing. We have the vertical change of 4 units. We have the horizontal change of 2 units. We get the same slope. So let's use our slope formula to find a few different slopes, given some points. So let's say this is x1 and y1, and this is x2 and y2. We can go ahead and take y2 minus y1 and divide it by x2 minus x1. And then we just solve. 5 minus 3 is 2. 2 minus 0 is 2. Simplify our fraction. Our slope is 1. We'll use our formula again. Let's write it here. y2 minus y1, x2 minus x1. So we'll say that this is x1 and y1, x2 and y2. 3 minus negative 4, negative 3 minus 5. So 3 minus negative 4 is 7. Negative 3 minus 5 is negative 8. So our slope is negative 7/8. And I just used our fraction equivalency to move that negative out of the denominator and just place it in front. Let's go ahead and do one more. x1, y1, x2, y2. 3 minus 0 divided by negative 2 minus 4 gives us 3/6, which simplifies to negative 1/2 for our value of m. And there's 3 slopes by using some points. We can do the same thing if we're given a graph. We can find 2 points just like we have up here. So for this, for example, we could say that this is x1 and y1, and this is x2 and y2. And we can take negative 3 and subtract negative 7. And we could take 0 minus negative 2. And that's where we get our 4/2 that we have here to simplify.